Hi and welcome. This time around I have a project where I'm making another fixture for the laser welding company, and it'll be taking this battery cover that goes on top of a battery, and it will the battery all gets laser welded together, and there is a center part that I'm not sure what the functionality is. I'm not even sure what this is, because if it was a terminal all by itself, both terminals wouldn't be welded like this, but in fact this part gets pressed in here and then rotated on a rotary table with the laser weld fixed on the side. There's no added material, and it's stainless to stainless, and it just takes the material that is proud here and welds it together with the lid. There's also a piece that goes in the center that needs to be laser welded, so I'll make a fixture that not only holds this, but that has an insert that'll hold this guy properly aligned. So my solution's a little bit interesting, and that's the journey. I spent a lot of time on CAD playing around with it. I made a bigger version of this for a much larger battery case they're using, and we'll see how that works out. I'm guessing that the terminal screws in here to the inside. This case ends up needing to be able to be pressurized to 30 psi with no leaks. Kind of interesting. So again, here's what the finished welded part looks like, and there's some test laser welds that did not pass inspection, but anyways, that's what they did. Here's some 303 stainless, and I want this whole part to be coaxial, so the hole that is going to hold the part to be welded needs to be perfectly in line with this part here that gets mounted in a 3-jaw chuck and rotated. So that all has to be coaxial, and there's some clamps that mount on the side here that hold the top plate flush during the welding process. So the first part, we're going to do the bottom here. We're just going to take off a little bit of material, and we're going to make this whole bottom section. Then we're going to flip it around here, and we're going to do the harder part, which is the top. So start simple and face off the end. This is mostly for cosmetics. Now we're going to reduce the diameter just a bit. Just taking off 100 thousandths at a time. I relieve the corner where this shaft meets the upper section. There's not going to be any force on it. That would make a spot where it's weak. But in this case, it's so that it can sit flat if their jaws are sharp there. So now we get to flip it around. So we're currently we flipped this around and we're peeling off material to get us down to dimension here. There are very few dimensions on this are critical. The placement of the two hold down clamps and the centering and size of the hole in the end. Those are the important values. The rest are not so much. Looking for roughly 0.125 here. So what I've done is the ends are actually roughly square. I've actually circumscribed some circles around the outside of these guys, and I actually want to go in a little bit just to have some rounded corners which aren't demonstrated there but are there. It's going to look kind of like that. Just this top bit here, this part is a rectangular function. So that rectangular part, if I take the diameter down to 0.86, from here to some point, roughly 0.7 from here, we should be good there. So I think we're going to reduce this next area and, you know, just let there be a slight taper at the bottom of this, because that won't matter. It might even actually look good, because this part obviously is not square. I need a left-handed part to come in from this side, but that actually is not going to affect anything. So I think it'll look good. So I'm going to do that. We're going to go in 104 thousandths, penetrate. Now we need to remove the remainder of this material down to the end. Might have done the order of operations wrong here. This might be very hard to work hold when I get down to the mill. That's going to potentially be a problem. So we finish this up to the final boring here. The rest will be done on the milling machine, where we've got to put flats in here, and all the flats are for clearance and mounting, so not super critical. Well, this flat is only in that it sets the position of where the clamps land on the top plate. But in the meantime, we got to bore a hole in the end here, and it's got to be very concentric with this axis, which it should be because I haven't moved anything. And we can hollow out the center of it because it's only going to be supported on this lip anyways, on this bottom flat part. So there's no reason to have a perfectly flat bottom bore. I can just drill a bunch of excess material and then bore the rest to the final dimension, which is what I plan on doing. So a number S drill is almost exactly the clearance hole down the middle of this. So we're going to drill that out first and much deeper than I need to go. So I've got place for chips to fall. And we're going to go in with our S drill bit. And my total depth is 0.444. I better slow this down for this drill bit. My total depth is 0.444, but I'm going to go in further than that, probably like about an inch. No reason not to have some extra depth there. It doesn't hurt anything, except I will go in there. Maybe I'll go in 0.7. That's the thickness of this top part. This part here, it's going to have big flats cut into it that are only 400 thousandths thick. This would remove a chunk of that, so we won't do that. No reason to weaken it. There's not a lot of forces on any of this though. If you haven't seen this before, this is my small boring bar adapter. I made this quite a while ago to hold radius cutters I've got. It even has a spacer shim in there for these really tiny bars. All right, so this is an incredibly small bore for an insert boring bar especially. They go a little smaller, but not a whole lot, I don't think. I have one that's somewhat smaller than this. This is a solid carbide shaft with a steel end on it. You start going into just solid carbide boring bars like the Micro 100 when you get out of it, you know, beyond this level. So just want to take a skim cut, set our X0 here. So I wonder if I can do like 20 thousandths cuts with this small boring bar. I don't really know. Let's give it a shot, see how it works. It might just deflect the hell out of it. In order to gauge the internal diameter of this, I could use the inside telescoping gauge, but I think it'd be kind of tough. So I'm using pin gauges instead. So this is 0.388. We're about 40 thousandths away. I'm taking 10 thousandths passes. That pin fits so perfectly, I can't get it out. I probably cooled it enough to make it shrink a couple tenths, and now it's locked in there. All right, we got our diameter right. The part fits in. I don't know if the depth is right yet. I went about 1.5 thousandths over, so there's a tiny bit of slop. So now the question, oh, I don't have this cut out yet, so this needs to sit flush. And it looks like we really do need those last like 8 thousandths. I think 10 thousandths might be too much. Yeah, I stopped early on purpose. I think we need to go to the depth I calculated. That looks good. It should be just a couple thousandths over now. And that looks good. That looks very good. All right, this part's mostly done. We need to take it over the mill and square this off for clearance, because obviously this part can't fit down over that yet, right? And then there's some flat spots here where the clamps get mounted that come over the top and grab this and hold it down for the welding process. Here's what this guy looks like so far. This part slides down in the 3-jaw chuck. This is the flange that stops it so it stays at a certain depth every time. And then here we have the step in there that holds the sleeve that's going to be welded. And we still need to make an insert for this guy that will hold the center pin to also be welded. So we'll do that before we leave the lathe, and it's over to the mill to flatten off some of these bits. For this one, fortunately, I don't have to bore it because I have a reamer of the appropriate size. So that's really handy. So I want this hole to be as flat as possible, a flat bottom as possible. And we're gonna use an end mill, which isn't perfectly flat. There's of course relief in the end mill, but it should be close. So it's still a little small. I could try and get a small boring bar, but instead I'm opting to take some sandpaper around a drill bit, wrap it tight. It's much smaller than the hole, well, smaller than the hole, and just work the sides. Well, that's a perfect fit. I hope the depth is right. It's hard to tell. I have no way to test it because I don't have a separate piece of this, the small piece here, so I'm not sure the depth is right there. Might have to remake this piece when I get one for real. Next, we're just going to part this guy off of here. We get the part. The tail of the part, the .875 part, was .875, so it fit in a 5C collet nicely, and it's sitting in the squaring block. And we're going to just take off 108 thousandths on each side of this guy, and just the end here to make it square so that it has clearance for the part. And then we will square up the inside here for the final part, which is where we will mount the spring, the pull latches that will hold the plate in place, actually everything in place while we're welding. And we finished the end here. We got some deburring to do, but that should fit nicely. Now we just need to flatten off two of the sides here for the clamps that'll pop up and over. Took off just a tiny bit more material, about 12 thousandths a side, and now it's a really nice fit. Should be perfect. Next up, it's hard to see, but we're going to do the flat zone behind here, and its thickness and everything is moderately important because what that controls is where the latch ends up on the part on top. So we've got to go down 0.267 a side. Very good, one side done. Now we can flip it over, and the second side's done. All right, so here's the part finished almost all the way. Just have to drill a couple holes and tap them. So that insert fits there. That's what's going to get welded to this. And this part fits on top. Oops. Like so. And then this clamp right here will sit back here and will pull tight right on the edge like so. I used the drawings that the CAD drawings that came with the McMaster car parts. Like McMaster car has drawings for almost every part on their site, but this one, obviously these aren't precision pulled draw pulls, so if I end up having a problem with this design, we may have to switch to another, but I think it'll work okay. It looks like the bar will be back far enough that it won't get in the way of the laser, which is going to go right around the edge there. Now the one thing I was thinking about was they don't want this bar to scratch the surface of this battery plate. The customer was not happy about that. So that's why I chose this one, because it's nice and rounded, so it shouldn't do any damage. So next up, we're just going to drill and tap the two holes here and hopefully get this guy to fit first time. Ha ha. All right, so here's the tool complete. I screwed on the two clips that go on the side. And if you want to see how it works, here's one that's already done. So it would sit like that, and then you would pull the clips on, put the clips on. This is pretty slippery. So they're right outside the laser area. If you're going to do the center post, it's a really close fit. This is the one I can't be sure of because I don't have a spare center post, but I think it'll work. So the center post would fit on like so, and it would be clipped down. Oops. These are a little slippery. There you go. So because these things are just spring steel, they're a little flexible and they can move around a bit. That's not ideal. So there's another type of pull draw latch that if this becomes unacceptable for them, I can swap in. So there's also this draw latch, this style here. The only problem with this one is that this has sharp edges on the end, which is not ideal. And they were worrying about scuffing of the top of the battery container. So I could switch to this style, but I prefer not to. So I'm going to see if this one will work for them. If it will, we'll go with it. If not, there'll be a redesign. But that's what happens when you're prototyping, right? All right, thanks for watching. Hope you find it useful. Hope to see you next time.